Good morning, everyone. Welcome to the DECA-LAB's third webinar on solar energy on coaches. This webinar is organized in collaboration with Sono Solar. So what's on the menu for this morning? First, I will start with giving a short introduction on the DECA-LAB project itself. After that, project partner Steven de Meijer from the KU Leuven will briefly describe the purpose of the solar panel tests and their place within the project. And finally, George from Sono Solar will take the stage to provide an overview of the product and the pilot program. After that, we'll end with the Q&A from the audience, if desired. So, DECA-LAB, in a nutshell, DECA-LAB, or the decarbonization of long-haul vehicles, spans a period over 3 years, starting on May 1st in 2025, and will continue until April 30th, 2028. Its main focus is the possibility and investigation of adopting alternative fuels and propulsion technologies for coaches other than diesel. Of course, the examination can also be used for all heavy vehicle transport, which also means for truck companies and the truck sector. First of all, we started with the examination of 16 alternatives of diesel fuel. As of now, we have narrowed them down to 5, which are battery electric, HVO merged with diesel, hydrogen with combustion engine, and hydrogen with a fuel cell. Our project partner from the VIVES is currently creating a matrix with all the information acquired from focus groups and interviews. Secondly, after creating the matrix, we will carry out tests with a fuel that we believe, in consultation with our advisory committee, have a potential future in the decarbonization of the coach and heavy vehicle fleet. These tests include conducting on-road tests, inclusive involving the solar panels, as well as laboratory tests at the VIVES Kortrijk facilities. Finally, considering the matrix and the tests, we will make a decision-making application, and that will be developed so companies will determine which type of fuel suits their needs, which is also the main goal, and the main goal being guidance for future fleet choices. The partners for the project are the Busworld Foundation, VIVES, KU Leuven, BAAV, and VEBETRA. This all happens with the support of VLAIO. Now I will give the floor to Steven, who will explain you more about the tests itself.
Yeah, good morning. Finding the right one. I assume you see my screen. So yeah, my name is Steven from KU Leuven, doing research here on everything which is about renewables, and especially also on what is this bringing also from a financial point of view. Does it bring any value? So what we do in DECA-LAB is a few things. So we do, and that's the topic of today, we do the research on what could rooftop solar panels bring on coaches or on trucks. We also take part in the other initiatives or aspects of the DECA-LAB project, but I will not go into detail of those. So what will we examine during this project to see what is it technical feasible? Well, as we have a provider in this circle, yes, it is, but how easy is the technical feasible? What could be a realistic range extension of having rooftops on your bus, and what are the different under different conditions? What could this range extension be? Is an impact on long term? Very important now, also with high diesel prices. Is there an economic business case? And to see if there's a business case, what would then the ideal sizing be, and under which parameters and variables? That is what we want to examine from a theoretical point of view, but also from a practical point of view, to do a pilot to see what are now the real data that we get out of the systems when we do some testing. So why would solar panels be interesting? Well, very briefly, if you have 1 liter diesel, that's about 10.6 kilowatt hour of energy. But unfortunately, this diesel loses some of his energy in the efficiency of the motor. Who gets warm? You cannot do a lot of things with the heat of the motor. Also, on the alternator, you still lose some more efficiency. That is going to the battery, and the battery then this energy, electrical energy, can then be used for HVAC, can be used for lighting, can be used for starting the engine, etc., etc. So, but instead of 10.6 kilowatt hours, you get very much depending on the conditions, how you drive. Are you driving a lot of start-stop, or are you driving on a motor highway? The efficiency will be very much different. And so also the electrical energy you get out of the system will be completely different. So the question is, can we help this a bit? By adding solar panels. The solar, as long as it's for free, the solar power, that's nice. Then it can be converted into electrical energy with, we love abbreviations at university, with a maximum power point tracker and a battery management system. You can charge your battery instead of having to do this via the diesel via the alternator. You can say, no, it can be charged via the solar panels. Question is, how much less diesel do you need then in order to have the same amount of energy? That is what we will examine in this DECA-LAB project. So what do you find already? Those vehicle integrated photovoltaics. If you see VIPV, that's the abbreviation of the name. Yes, you do see them, and already a different kind of cars. The efficiency of solar panels, by the way, keeps on being increasing. Here you see the different types of solar panels. It's just a visual, but you do see that over the years, the efficiency of solar panels keeps on increasing, so the technology keeps on being better. At the right-hand side, you do see the price of a watt peak of a PV module. There you do see the prices per watt, what you get out of it, keep on declining. So yeah, that's a good way to go. So let's see if we can use those. Of course, what we will use on a bus or a truck is not these kind of cells, which are fixed ones, which ones you use on your rooftop at your house. We will use more light ones, flexible ones, and you have different type of technologies. I will not go into detail of those. But that's what we will look for, or both a flexible like this one, or another one, which is a bit different type of technology, but that is what you can use. Is this something you can put on a bus? Well, I have looked at where do you find solar panels? You find them in space, you find them on glaciers, you find them during war, you find them on the sea in the North Sea at minus 20 degrees, or on the North Pole, or at the equator at 50 degrees. They still keep on working. So yeah, you can use them in harsh conditions. So also on a bus, also on a truck. But of course, what you get out of those solar panels very much dependent on two big parameters, being, are you driving in Spain during summer, or spring is even better, or are you driving in Norway in the winter? The amount of energy you will get out of your solar panel, of course, that will be different. Also, the lighting condition. Do you have a lot of shading? Are you driving in a city center with a lot of shading? It will be completely different than driving on a motorway. That seems also logical. So do we see potential on solar panels? We did already some literature research. Yeah, there is. But there are very limited studies on the long-haul autobus transport. So there you do see on trucks, you do see on city centers. So we would want to examine this also on the long-haul autobus transport. The proof of the pudding, of course, is in the eating. So that's where we want to do not only the theoretical part of the study, but also a real pilot to see with the provider, what do we get out of the system, and what do we think can be the economic and energetic value. But of course, we will need some people who want to participate also in this pilot, and that's what we also want to inform you about. But on that, we will come back later on. But if anybody's interested, or you have already questions, don't hesitate to mail me. You have my email on the bottom of this page. That's it for me. Georg, I think it's up to you now.
Yes, many thanks for the warm and good intro already. I'll share my screen as well. Quick feedback, can you all see it? I assume yes. Perfect. Cool, then good morning from my side. Shortly to my person, I'm Georg zur Mühl. I'm the head of commercial at Sono Solar. Since almost 7 years in the company now, quite a long time. And yeah, I'm very happy to present a little bit on how we deal with the solar integration topic. And as a first intro, basically, I know it's the third webinar, so I tried, and of course I also have been looking partly in the other webinars. So I on purpose tried to cover a little bit different topics, sometimes a little bit other topics. Of course, I will first introduce you in the way how Sono Solar is doing as a company, how we live and do solar integration. But then I will also talk about diesel savings, about potential of solar integration, but I will also put a light on some other aspects you might don't know about. And of course, I will also give you an indication how a concrete project with us would look like. Please dare to always ask questions in the middle. I think we will have a Q&A session in the end as well. But if there is anything not clear from what I'm presenting, then of course I'm happy to answer. And I see it's great to even have people directly joining from the coach. So I like this hands-on. So about Sono Solar, our company, maybe some of you know us as Sono Motors. We are basically already in the market since almost 10 years. We have been developing this solar electric car called the Xeon. Yeah? So solar integration is in our DNA. We have been pioneering solar integration since a very, very long time and really got in this very difficult field of how to integrate solar into a passenger vehicle. Yeah, so we really know what we're doing. Unfortunately, you probably also know, similar to Lightyear, we had to stop the car project a couple of years ago due to financial limitations, but basically have been able to move all our knowledge, all our expertise in the other business unit, which we had been ramping up already, which is basically using our solar integration technology, which we have been developing in-house to all kind of solar integrations for commercial vehicles, buses, trucks, vans. Where does solar integration make sense and where do our customers actually come from? Yeah, so we are basically spread over a wide variety of vehicles. Our customers come a lot from the refrigerated vehicles industry, where vehicles benefit heavily from solar because you can extend the operating hours, you reduce energy consumptions, you save costs. It's just a positive impact on TCO. Of course, what we're mainly talking about today, buses and coaches, they have a high power demand for site consumers, as Stephen and Louis already said before, and solar integration helps tremendously to reduce these demand. Also, very important business for us is delivery trucks and vans. So also for everyone who is rather from the truck industry here joining today, this is also a very interesting use case. Delivery trucks and vans have a very battery draining work profile, and solar is a perfect match for that. Electric vehicles, of course, is super interesting, extending the range with solar and increasing the vehicle uptime. And also we are working in the solar electric boat industry. This is also a new business basically ramping up now as there's more and more electric boats. And of course, solar on the sea makes every sense. What does Sono Solar maybe do a little bit different from other manufacturers or other providers, as you heard in the last couple of weeks and months? So we have on the one hand a very strong technology offering. Yeah, so we develop our solar charge controllers specifically for vehicle applications on our own. I will say a couple of words about that in a minute. We also have qualified and tested a lot of PV modules. We don't produce PV modules on our own, but we have basically selected the best PV modules which are out there in the market and use them for our products. And we have also a data product, a dashboard, solar dashboard developed in-house. We have all kinds of simulation services which prove basically the value of solar integration. Yeah. So these are the technology blocks which we have been developing, qualifying in-house. And these technology blocks we take then, which you see on the right upper corner, we put together to all kinds of solar kits, solar systems, both for retrofit and also initial integration. And this again goes for delivery trucks, for refrigerated vehicles, for buses, coaches. Yeah, we put all together our technology blocks into kits, into solar systems, which you can directly buy, install yourself, get installed by us, and always made perfectly for this specific vehicle type, for this specific vehicle application. What is very special about us, I think, is that we are also very heavily involved in work with vehicle OEMs. Yeah, so both on the trailer truck side, but also on the bus side, we have concluded already several projects with bus OEMs, integrating our solar solution into their buses. This mainly comes from our very year-long experience. We do not come from the solar industry, basically. We come initially from the automotive trailer truck industry. Yeah? So we understand very well all the demanding requirements from this industry and copy them, basically put them on top of the solar industry. So this is what makes us very special. And last but not least, our solar data engineering services. We have a special dashboard, we have simulation services, which we have all developed in-house. I will also say a couple of words about that in a minute. Looking into some more details, why are our solar modules very special? So I already said we have been testing and qualifying our modules heavily. So we have been testing, qualifying over 40 different module types of these monocrystalline solar modules in the last years, and basically have selected the best modules which are out there in the market and which we see in all our harsh tests really survive the heavy demands, the heavy requirements we see, the harsh conditions we see on the road. Yeah, so we can proudly say that our modules are really extremely reliable and robust. They have a pre-assembled tape on the backside, which makes them super fast to install. They are, as Stephen already mentioned, we only use the monocrystalline solar cells, so the high efficiency solar cells. We don't work with CRGS at all because we believe that we need highest power density on our solar modules. These modules are, of course, also thin, lightweight, semi-flexible. Yeah, so you don't add a lot of weight to your vehicle. And as said, they are completely designed, validated, qualified for automotive applications. The test procedure is very complicated, which we have been setting up. Our engineering team has basically set up an own testing environment for solar modules. And as said, all these 30, 40 module types, which we have been testing, all had to go through these testing cycle, and only very, very few of them really survived all of the tests. And basically, these are the modules which we have selected now for us. This is also why we give 5 years warranty on our modules, which is higher than the solar mobility industry standard. As said before, maybe the most important thing about our company are our solar charge controllers. Yeah, we have a very long experience of developing electronics. And we have been developing our electronics initially for the solar electric vehicle, the Sono, which I mentioned before. So we already thought about, 7-8 years ago, we already thought about how to bring actually solar energy the best way into a vehicle. And we have developed several different types. One type is for buses, for example, charging the 24, 48 volt board net. The smaller charge controllers charge 12 volt, 24 volt, but we even have developed a solar charge controller, which is capable of charging directly into the high voltage system, to the directly 400, 800 volt system of battery electric vehicles. And this is a quite unique point in the industry. Yeah, it is not required in any use case. So in the bus industry right now, charging the low voltage board net is anyhow the right strategy. But long term, if you look at all kind of electric vehicles, turning them in real solar electric vehicles, you need exactly this kind of unit. The good thing is we have developed it completely in-house, software, firmware, hardware, so we can do every customization which is needed, basically, very fast. This is also one super major advantage why it's easy for us to work with OEMs, because OEMs always have their own ideas and demands and requirements, and this is basically what we can easily react to. Very special about our charge controllers is the fact that we use a parallel multi-channel architecture. Normal charge controllers, which you often see, also what you know from house roofs, they put all solar modules in series and then come up with a very high voltage in the end and charge this high voltage into the charge controller. We know and believe that for vehicle applications, that's the completely wrong approach. Yeah, it's important to have a parallel connection of all modules. First of all, to stay always on a safe voltage level of below 60 volt. Yeah, this is a fact which is more often not considered properly than you think. Yeah, so if you have ever dealt already with solar integration in your vehicles, really make sure that the modules stay and the charge controllers stay in every condition, in every driving condition below 60 volt. And the multi-channel parallel approach also brings us the value that we track the performance of each string very individually. So if you have some of your modules shadowed, maybe very dirty, dusty, which can happen on a bus, or if even 1 or 2 modules maybe have broken after 7, 8, 10 years, then that doesn't harm the overall performance of our system, because with our parallel approach, all other modules still work at their best optimum level. And this is what makes our solar charge controllers so unique. Another thing, which I will also give you a little bit more of a deep dive later, is our smart charging algorithms. We adapt to the fast changing sun conditions while driving within milliseconds. This is also super important. If you don't do that and the sun conditions are changing fast, but you always optimize your system towards a certain power point, then the system will never really earn a lot of added energy. On top, our systems can communicate via CAN Modbus, so that's also for integration with the OEMs a key feature. What I mentioned before, the solar dashboard and the yield simulation is another cornerstone of our offering. You see here basically the Sono Solar dashboard, which everyone who buys a solar system from us basically gets automatically. Yeah. It's a web browser-based application, and you can control and see anytime basically what your vehicle has really gained on energy, which is, of course, especially in a project like we're talking about, the key feature. Yeah. Otherwise, you never know what your solar system is actually doing. You can export all relevant data which you want to export. And again, as we have been developing it, all kind of customization is possible. Yeah, so we also are working on customization for OEMs who want to have it white labeled, who want to have it in their own design. Then of course we can just adapt it to their needs. And also very important, what we can also do, especially in this project, you see on the left bottom corner, you see how our standard simulations look like. What we do is we simulate the solar energy of a potential use case by using real weather data of the last 15 years. And we can predict very, very well how the solar yield will be. Yeah, Stephen explained that already. There's a lot of options to do that. And we have a very well validated model to simulate the potential solar yield. Last but not least, as said before, our engineering services are heavily used by different OEMs from different industries. So, for example, with Ford UK, we have been creating already a high voltage solar charging interface to really charge the e-transit with directly the 400 volt battery with our solar system. Thermo King, one of the biggest players in the trailer industry, we have been developing a solar system for electrified refrigerator vehicles. And coming today to the most important topic, MAN is the first bus OEM who is offering right now factory installation of our solar system. It's right now a accessory. Basically, you can order it as a special accessory, and MAN is installing it in their factory in Turkey directly before delivery of the vehicle. I hope I could give you a little bit of an insight what we are doing special and what our product portfolio looks like. And I would now go a little bit more into a technical deep dive, because webinars there also to learn a little bit new insights, perspectives on how solar integration works and how solar integration can actually help. So how can we really assure that we reliably save fuel with solar energy? Because of course, at the first glance, it sounds super logic, it sounds super easy. You have solar panels on the roof and they charge the battery. Yeah, easy. But, and this is something which I want to emphasize on, be very careful on how the system is looking like, because otherwise it won't be successful. The key requirements that you're really able to save fuel with solar systems is, first of all, of course, you have to be somewhere where a sunshine pattern is reliable and predictable. There is regions on the world basically where solar integration doesn't make sense. Depending on the region and driving profile, we recommend systems for 1 to 2 kilowatt peak. Also, smaller one can save fuel. I will say about some more words about that later on. But we see clearly from our customer data that a certain amount of power installed is recommended. Why? The amount of energy which is used by a bus for site consumers is quite high. Yeah, so you can completely eat up a lot of solar energy directly to reduce alternator load. What is also basically advantages for good solar integration is if the use case involves idling situations in the driving profile. And then going a little bit back to Sono Solar, the charge controller you should use has to have the capability to adjust in real time to shading. Otherwise, the charge controller will never really gain proper energy. And the charge controller has to be able to deal with the board net voltage. And this is now the tricky part. What does that actually mean? And this is what I want to explain a little bit more now. The role of the charge controller. You know, it's probably not new to all of us, the electrical consumption for all auxiliaries of buses is roughly 500 watt to even 4 kilowatt. And this electricity, these auxiliaries discharge the 24-volt battery, and this burns fuel. The engine burns fuel to recharge the battery. This is how every bus works. Normally, up to 3 alternators are connected via belt drives to the diesel engine. And those alternators adapt constantly torque and voltage to the 24-volt consumption in the vehicle. So it's never directly 24 volt, but it's sometimes a little bit higher, sometimes a little bit lower. And what we need to do to really save fuel, we need to detorque the alternator. Yeah, because if the alternator is constantly running, you have no chance to really bring solar energy to the vehicle. Yeah, so it's important that the board net is fed with solar energy at a slightly higher voltage level than provided from the alternators. And most of the solar charge controllers are not capable of doing so. And of course, I can say our solar charge controller is capable of doing so. Yeah, solar charge controllers have to be technically capable to react to these conditions. Otherwise, the gain solar yield during driving basically vanishes in the system, and you don't have an impact. You can measure a lot of sun energy coming into the vehicle, but it never really reaches the battery or the board net. Our solution, as said, our solar charge controllers do exactly that. Yeah, we tackle exactly this issue. We constantly measure the board net voltage fluctuations, and we add a tiny voltage amount, 0.1 volt, basically on top of this system voltage. And with that, we make sure that the solar energy is always fed with priority, so with a slightly higher charging voltage to the board net. And only with that, alternators really detorque, and with that, automatically the engine burns less fuel. So also real fuel savings are achieved also when you're driving. And we see a lot of systems on the market where you have standard solar charge controllers, you have smaller power outputs, they normally don't adapt the charging voltage. Hence, during driving, the energy is often just lost and vanished in the system. And those systems provide charging reliably only when the vehicle is parked and the engine is off and the alternator is not running. But of course, this doesn't help you so much to really save energy and really save diesel. And these systems are often then rather focused on keeping the battery health up than real fuel saving. I think this is the key fact about solar integration, and I think this is something which, yeah, on the first glance you normally don't think about. And often, if you see on the market, you see a lot of solar energy coming in, but often you also don't really see it then in your savings. And this might exactly be the case why. And this is why we are on purpose doing it differently. Now, coming to the next topic, benefits. I think about the diesel savings, you have heard a lot of other topics in the webinars, in the other webinars already. Stephen said some words, and of course, we also want to find out altogether how the diesel savings are then in the end from long haul buses. This is why I want to go a little bit differently as well today and give you a little bit more physical insights and coming from a little bit different side. Please apologize for having a half German slide. You see, this is a Sankey diagram for a bus, and you see on the left side you have a fuel input of 40 liters per 100 kilometers. But where is this energy actually going to? Stephen already mentioned it partly, that it's super inefficient and so on. 65% is energy losses. Again, super frustrating to read, honestly speaking, when you know that there's electrical engines out there who are way more efficient. But that's the reality. About 20% is resulting in really driving energy. We have auxiliaries in total of 11% roughly, and you see it at the top and at the bottom. The alternator, which is really the use case for solar integration, basically, is at around 6%. So physically, for a driving bus, this is the maximum amount of solar energy you can save. But very important to say that this is about a driving bus. It's a sort cycle, so certain idling situations are considered there. But of course, if you have more and longer idling situations in your use case, which is often the case, then of course there is ways higher potential. So the number can go up ways more. And in the end, the real savings depend on system usage and solar system performance. But this is somehow the physical boundaries which we see. On the other hand, to be said, it's crazy, right? Like you can save 6% of the energy is just burned for auxiliaries, and you can cover this complete amount with solar energy. So really to get this background straight. What I want to take you a little bit on a bus travel journey, because we see you know a lot about solar diesel savings in general and so on. You heard, I think, in the last webinars a lot. But we see a very interesting use case is a travel coach. On a travel coach, and we try to visualize basically one day of a travel coach. You see on the bottom left, 7 in the morning. The bus driver, vehicle preparation on board, the travel group is coming on board and so on. So the bus is probably running somehow in the city. Then for a couple of hours, the drivers are driving to the destination, the blue bar. And then later on, you have a small break of the driver, you drive again, and then basically you're probably in a city, and you drive to your city destination, and then the coach is parked for a couple of hours from roughly 2 to 4. And then in the evening, you drive to the hotel, and then you park for the night. And now you see the different driving and efficiency behaviors there, right? So on the right side, you see on the motorway, fuel efficiency improvement constantly only during driving is roughly 2%. The moment you go into the city center, which every bus is doing, then you immediately increase to you add basically to this 2%, you add 3 to 5% for these times. And then when you have parked the bus and you would normally idle the bus because you want to run your auxiliaries and you don't want to drain your battery, you would normally keep the bus idling. Now with solar, you can stop that, at least partly, yeah, not completely, but at least partly. You can reduce the idling time, the engine idling time of your bus. And with that, here not talking about percentages, but talking about 3 liters per hour, basically, yeah. So with every hour, you reduce, with every hour, you don't idle your bus because of solar integration, you save directly 3 liters of diesel. Means half an hour per day, 1.5 liters per diesel saved. You see that this travel coach is a very interesting use case, yeah. And as like we know, we talk about long haul, and travel is part of long haul, basically. Though this is why I wanted to give this insight on this very special use case. Yeah, and I think this is maybe one of the most underestimated uses of solar energy, and I will talk a little bit more about that as well, because solar energy brings more comfort and better vehicle availability as well. So we have, besides fuel and CO2 savings, a lot of advantages, especially for coach applications, which you maybe don't think about in the first glance. Yeah, and one typical situation, for example, is the preconditioning of the bus. So before the travel group is coming back from their visit in the museum, the driver can vent the coach by solar power before the travel group enters. Yeah, normally you would idle the bus, you would turn on the engine, and you would run the cooler. And with this, you can additionally faster cool down to the target temperature, and that saves fuel during the first driving minutes. So you save in this kind, you save again fuel, but you also enhance passenger comfort. And like we know it from coach travels, even in the most expensive coaches, in the first minutes after onboarding, you have basically unacceptable temperatures when engine idling is not permitted. And this is very often the case now in some cities, especially in Southern Europe, that you're not allowed anymore to idle your bus. And then the passenger group is coming back and has to enter a completely hot vehicle. And again, here, solar can make a huge difference because you can enhance passenger comfort. You can make your passengers happy. And again, you save fuel with that. And second very important thing is also buses who are partly in service and maybe also then stand around for 1 week or maybe sometimes even 2 weeks. Then we often have the issue of batteries being drained when the coach is parked. And that, by the way, is exactly the same for every truck, of course. They are not just talking about coaches, buses, but this is exactly the same case also for all kind of vehicles. And solar saves the starting ability on tour. Yeah, so we prevent early and annoying replacements of these batteries. That saves money and that saves a lot of frustration. Last but not least, what we call a silent comfort. Yeah, you can, as mentioned before, you can run all your auxiliaries without engine idling. Still make your passengers happy, make your driver happy, because they don't need to sit on the vibrating diesel engine all the time. But instead, during all kind of travel pauses, you just use solar energy for that. And that brings a lot of comfort besides very big potential for diesel savings. Now, I hope I could entertain you a little bit with this little bit different approach to benefits for solar integration, not repeating too much what you had already known and heard. Now coming to the last topic already about the concrete project. I think most of the stuff is now somehow repetition, but of course I want to be very as precise as possible. So if you purchase a product from us, such a solar system for buses, of course you always get solar modules, including all cabling. We have those solar modules both with front connection and with back connection. Yeah, I will say a couple of words about that as well. Front connection, so where the cables are coming out, just to be very clear about that. And with the back connection, you can of course get a very clear and neat solar integration. This is what OEMs normally choose. They don't like to have any cables on the roof. They're super happy if the cables are running inside the bus, because then you basically have a super aerodynamic smooth solar integration and no annoying cables on the top. But we basically offer both, and we can decide with the customer what to do. Of course, always our solar charge controller is included. Yeah, the magic unit I was talking about before, and then always the solar dashboard is also included. Yeah, so of course you get all the data access to all the data, which is very important for controlling the performance of the system and reporting the performance of the system. And of course, all installation materials, all cables, everything you need to do the solar installation is also included. Regarding system costs, it's also hard to say very clear where we end up, because it heavily depends on how the bus is installed, how the roof layout is, how big the system is. Of course, bigger systems normally are cheaper per watt than very small systems, and so on. In general, the numbers you can take with you already. We are ending up normally between 2.5 and 4 euro per watt, especially depending on volumes, of course, as well. Yeah. So for pilots, we are rather at the higher side. For smaller, for higher volumes, we can then really offer very attractive pricing. Now, this is something which we have been talking about as well, the right size of a solar system for buses and coaches. I think we are here a little bit more pushy towards bigger systems. Why? We see, as said before, we can save up to 6% fuel during a sort cycle, but that only works if you have the decent amount of power. If you make the solar system too small, the energy will be eaten up all the time. And we see it in all the buses running out there with our solar systems. Normally, the energy you need, the electrical energy you need, is always higher than the solar energy you can provide. Yeah, so we always see our solar energy is basically never stored in a battery. It's always directly going into the consumers. This is why we engage to say larger systems definitely make sense to really save fuel. Yeah, so city, bus, into urban, we normally plan 1.5 to 2 kilowatt peak. Coaches, sightseeing, it can also be a little bit lower, 1 to 2 kilowatt peak. Only for coaches which are purely running on highways. Yeah, where you don't have basically a single minute of city traveling. Yeah, these are systems where also smaller systems make sense, because the engines already are running more efficient on the highway than in the city. Yeah, so here also the energy demand is not so high. Yeah, and then it makes sense to dimension the systems a little bit smaller. But that's, in my opinion, really only for the cases like Flixbus, which are barely running in any cities. They're just going from city to city, running millions of kilometers per year. How we install, basically, it's completely openly speaking, it's also not totally different from others. But what we do very special is with our cabling. Yeah, that we are able to put the cabling inside the bus, yeah, which makes it a super sleek and an OEM-like installation. Yeah, so on top you have the solar modules. I said already they have a pre-assembled tape on the backside. So we just need to clean the roof, primer it, and stick it on. Stick and peel, basically quite straightforward. Then we route all the cables along the roof to the B-pillar, and then towards the charge controller and the telematics unit, which we need for the solar dashboard. Where we install the charge controller depends on the bus type. We have it sometimes in the overhead compartment. We have it sometimes in the overhead of the driver. We have it sometimes behind the driver's seat. That's basically depending on the bus type. If we talk then concretely, if you name us the bus type, we are basically able to tell you where to mount it. And then normally we run the power cable. Very often in coaches, that's the case. We run the power cable under the gangway, basically in the luggage room, and then to the switchboard. And in the back, there is the charge controller. Again, here, it differentiates a little bit between retrofitting and directly working with OEMs. The OEM can, of course, do the cable routing a little bit easier than we can, basically, before the vehicle is ready. Yeah, and then we sometimes have it a little bit differently done than if we do a retrofit. But this we will decide together case by case. To repeat that again, because this is super important for me to say, you see here again, for example, a system with 12 modules on the roof. And this is exactly, again, this advantage of our multi-channel solar charge controller. Yeah? So if you see here, for example, one module at the back is shaded, you're parking somewhere under a tree and one or two of your modules are shaded and the rest is full in sun. If you don't use multi-channel charge controllers like we have, that would mean you reduce the full energy yield you get to a super low value. And only with our system, we basically track every channel independently. So all modules which are in sunlight gain a lot of energy, and only the modules which are in the shadow gain less energy. Just to repeat that, that's super important. And in parallel, in all conditions, the system on the roof needs to stay below 60 volt. And that sometimes with some kind of modules and some kind of charge controllers, that's not granted. Just two example layouts. We have two modules which are normally the front runners for bus applications. We have plenty of more module sizes, but these two are normally the front runners. You see one which is 2 meters times 0.5 meters, and one which is roughly 1 meter by 0.5 meter. 100 watt and 180 watt. And these are the modules which we normally put on the roof. We can also combine them, so we can make basically the best roof layout for all of your roofs, depending on how you need it. And as an example, again, you see basically that every module gets an own channel, and gets basically the best performance. To close, I think the next steps from our side would be rather straightforward and easy. So if you decide on a vehicle, basically let us know what the vehicle type is. We will design the roof layout, the system dimensioning, discuss basically your use case, and decide together how big the system should be. What I mentioned before, we can do solar yield simulations for specific use cases with our simulation model. So we already can predict basically what solar energy you can expect. Then installation at a customer or service workshop. And last but not least, I want to come back to this topic. We have this very big upside potential of collaborations with OEMs for factory installations. So our system is also made for OEM installation. It meets the standards of OEMs. I know in this project, probably if we talk first about prototyping or piloting and retrofitting, but in case you have basically the ability, or you're planning anyhow to purchase a new bus, for example, then please let's get in touch and let's see if this is anyhow with one of the OEMs we're collaborating and maybe are able to basically make a joint project out of that, and you basically get the system even there. Closing with that, I think what I can proudly say is that what is I think makes Sono and us as a company unique, based on the expertise which we have, which is very long, and the expertise coming from automotive industry, coming from truck trailer industry, coming from bus industry. We could convince there was a couple of bus OEMs already to work with us. So right now we're working with 6 OEMs on integration of its solar technology. MAN being one of them. I cannot spoil all the other names. It's not there yet. But of course, in case we go into a concrete project, please reach out to us. We have more than 60 buses delivered so far with our solar systems on top. So we have a lot of experience in the field. They are both retrofitted and integrated by OEMs, and I believe this is a fact why we can be a very good partner for you in this project. Last but not least, my contacts, and also the contacts of my dear colleague Jörg, who actually should have held the webinar today, but unfortunately is relatively sick. He's back today at work, but it was too short notice, so I took over. Thanks anyhow for the good preparation, Jörg. And Jörg will be basically your contact person in case of any projects. So I don't know, maybe you want to say hi quickly as well, Jörg. You're in the call. But please, if you want to directly reach out to one of us, scan the QR code and do so.
Thank you very much. I don't want to say too much because my voice is still not there. I'm Jörg. Hi. have been working in the bus industry for more than 20 years in the development, and since 4 years I'm now with Sono Motors as product manager for solar bus installations. Thank you.
Thank you, Jörg. Yeah, that's it. Looking forward to receive any questions now, or of course, after sharing the presentation slides and so on, then also in the next weeks. Really looking forward to this project.
Yeah, thank you, Jörg, for this very interesting and George for the very interesting presentation. Indeed, if there are any questions, feel free to ask Jörg or George now. While they're still here, of course.
Well, gentlemen, if I may, I'm from Emma in Belgium, and it's a bit of a surprise to me that there is already an installation on an Emma in Lions coach. But of course, we are very happy that you have this collaboration. Could you provide me with the technical installation, some plans, or that I can, from my side, get back to the people in Ankara and
Yes.
ask for
Sure.
it?
More than happy to do so. Welcome and thanks for the questions. And yes, we are always sometimes a little bit lost in translation between MAN Turkey and MAN Munich. This is why I'm not so surprised that this is maybe the same case for you. But of course, we can provide you all the information and follow up the next steps internally then.
Okay, great. And secondly, if I may, we do have a lot of e-buses in Belgium, in the Flemish part, where we know that the installation from the lane is consuming a lot of energy while the vehicle is standing during the weekends or the long weekends. And we always recommend our customers to cut the current during stays of 2-3 days. But of course, it would be very helpful if we had one solar panel maybe, just to charge a battery while the vehicle is not used for a few days. There's not an issue if the vehicle is standing during the night and operated again the next day, but we measure currents of 1 to 1.2 amps all the time, even when the vehicle is standing. So we need to compensate this to avoid issues.
Exactly.
We would be very glad to do a test with you. We ordered some stock vehicles that will arrive in May, and maybe we could do a test on a stock vehicle. It's up to you.
Yeah, sounds definitely very interesting. Let's do so. And yeah, this is exactly one of the smaller applications we see a lot in the truck business as well, truck and van business. And it's exactly as you say. I think drained batteries. So far, most people, when thinking about drained low voltage batteries, thought about diesel vehicles, but in fact, it's exactly the same case for electrical vehicles. Yeah. And this is a use case where we already are working on. So perfect to see, and looking forward to exchange on the details here.
Great, thank you.
Thank you.
If there is anyone else who wants to ask something to the people from Sono, just feel free to. If not, you can always send me the question. I will get in touch with George and Jörg, and then I'll get back to you with the information. So once again, thank you for joining this webinar. This webinar has also been recorded. It will be placed on the website soonish. For the further steps, we will be sending out an email from the project DECA-LAB itself with a registration form, so people can sign up if they're interested in joining the pilot program for solar panels. But this will happen within the next week or the week after. So once again, thank you all for joining, and I hope you learned something new today, and we'll be speaking soon.
Thank you very much.
Thank you for your attention also from my side, and have a great Easter time.
All right. Bye-bye.
Thank you.
Bye.